Welcome to the Sivat Science Hub. Today is the beginning of our course content. This video covers the chapter 1 of class 10 and also explains the concept of force as you have learned in class 9 second chapter. Force. Let me guess. You probably read force in a textbook as pull or push upon an object, right? While this cannot be classified as entirely wrong, it barely explains anything about the concept of force. Okay, let's imagine a person is pushing or pulling a heavy load. No doubt, force is applied and the load moves. However, this does not explain the concept, mathematical form, and the consequences of force entirely. Before we move on to the depth of the chapter of force, imagine a ball which is lying stationary on the ground. There is no human pulling or pushing. Now, is there any force that is acting on the ball? The answer is yes. There are mainly two forces acting on the ball. The first one is called the gravitational force, which is trying to pull the ball towards the center of the earth. And also, in accordance with the Newton's third law, the ground is also applying an equal force exactly in the opposite direction, which is called as the normal force. Remember, an interaction with another object is important when we describe force. There are two things that we will discuss in this video: an introduction to the force and the model of the universe. Before we actually dive into the chapter, let's check the curriculum. There are several contents in the chapter, but importantly we will study gravitation, Newton's law of gravitation, gravity, acceleration due to gravity, mass and weight, free fall and weightlessness in more details. And the total number of credit hours for this chapter is 8, out of which 6 is for theoretical and 2 is for practical purposes. So we discussed a moment ago about the force as push or pull acting upon an object as a result of its interaction with another object. The word force is an old French which means physical strength, and that infers how strong the person is in pulling or pushing a load. Now it has been clear that the force is an external agency that changes or tends to change the position of an object. For simplicity, we can classify force into two types: contact force and non-contact force, also called as action at a distance force. Contact forces are just like what they sound. These are forces that results from the interaction of two objects in contact with each other. For example, a ball kicked comes to rest due to the opposing frictional force from the ground. Non-contact force acts over a distance. These are forces that results from the interaction of two objects not in contact with each other. Example, a ball thrown up the air comes to the ground. Here the earth is not in the contact with the ball. So contact forces includes frictional forces, tension force, normal force, air resistance force, applied force, spring force. While action at a distance force include gravitational force, electrical force, magnetic force. Here in this chapter we will explain only about the gravitational force. Force was first described by Aristotle. Things on earth fall or rise because they find their natural place. Similarly, planets and other heavenly bodies move due to various, usually supernatural forces, and this led to Aristotle to describe a force as a supernatural thing. Later, force was mathematically and theoretically described by Sir Isaac Newton in a book called Philosophiae Naturalis Principia Mathematica. The book states the laws of motion the laws of universal gravitation, and many others, which are out of the scope of this syllabus. And in this book, Newton's unified the work of various philosophers at that time into one scientific formulation that could explain accurately the models of the universe, as we shall see. Now let us discuss models of the universe. There are two major models of the universe. They are geocentric model, also called as Ptolemaic model, and heliocentric model, also called Copernican model. The word geocentric is derived from two Greek words. Geo means the earth and centric means at the center. Literally, we can define geocentric model as the astronomical model in which the stationary earth lies in the center and all the other planets, the moon and the sun, revolve around the earth. So under this model, the sun, moon, stars and planets all orbited the earth. The nearest orbit was of the moon, while the farthest orbit from the earth was pre-mobile. There were two main observations that led Ptolemy and other philosophers to support this model. From the earth, the sun, the moon and the planets, they appear to revolve around the earth once per day. This motion is called apparent daily motion, and it will be discussed in the next slide. The second observation is that the earth seems stationary to an observer in the earth. This doctrine was so valued that it suggested that God made us something special, and hence it was incorporated to Roman Catholic Church. In the previous slide, we discussed that the first observation that led philosophers to believe on the geocentric model was the apparent daily motion. Let me illustrate you the apparent daily motion. If you look at the clear sky, it appears as if the sun, moon, clouds or stars are moving across the sky and that the earth is completely still and stationary. This is just an example of the apparent daily motion, and this was explained by earlier philosophers to suggest that the earth was stationary and everything revolves around the earth. After being accepted for about 1000 years, various other scientists discovered new ideas and ultimately heliocentric model was proposed. These new ideas and theories are out of the scope of your syllabus and hence not discussed here. Now let us discuss the second model, also called heliocentric model or Copernican model. It is derived from two Greek words. Helios means sun and centric at the center. The astronomical model in which the earth and the planets revolve around the sun at the center of the solar system is the heliocentric model, and it coincides with the solar system model, and the planet movements could be described in a more simpler way. There are various features of this heliocentric model which actually are out of the scope of your syllabus, so let me just read it. Heavenly motions are uniform, eternal and circular or compounded of several cycles, also called epicycles. These are the form of circles. The center of the universe is near the sun. Around the sun in order are Mercury, Venus, the Earth and Moon, Mars, Jupiter, Saturn and the fixed stars. The Earth has three motions: daily rotation, annual revolution and annual tilting of its axis. Retrograde motion, also called the backward motion of the planet, is explained by the Earth's motion. The distance from the Earth to Sun is small compared to the distance to the stars. So these are some of the features of heliocentric models. Heliocentric model was proposed. It was assumed that the orbits are perfectly circular and that the planets moves in an uniform motion. However, studies suggested that the orbits are actually elliptical and there are many different kinds of motion called as Kepler motion. And this initial heliocentric model was refined by Kepler and Newton to explain all these phenomena. The heliocentric models and the Kepler laws reveal the path for Isaac Newton to establish the Newton's law of gravitation. So the Newton's law of gravitation are entirely based on heliocentric model and some of the Kepler's laws that were later modified. So here, this is an illustration of the heliocentric model. We could see here that the sun is at the center and all the other planets are revolving around the sun. Now let's compare the heliocentric model versus the geocentric model. The yellow spot that we could see in the video is actually the sun. In the geocentric model, it seems to be a mobile object. However, in heliocentric model, the sun is stationary and all the other planets are revolving around the sun. I hope this clarifies you about the different types of models about the universe, and we will discuss more in the next videos and next chapters. So thank you for watching. Please subscribe my channel, follow my Facebook page, and visit my website for more course content. Thanks for watching.